Hello everyone, welcome to my channel. This is an educational channel and we try to look at some great theories of everything that can help you in your life to navigate every situation and possibly replace your old paradigm and be able to see things holistically. So today is our 360th video on Dewey B. Larson and his reciprocal system of theory. Mr. Larson was born in 1898 and served in World War I and went to college out in Oregon. He was born in North Dakota and stayed out in Oregon, became a mining engineer, and around 1930 he had a few epiphanies about some chemistry problems that he was working on, trying to kind of make a contribution to the field, and ended up getting more than he bargained for. He was just looking for some minor innovations, and he ended up with this huge revolutionary idea that would turn everything upside down. And he answered the call and he pursued his findings, and eventually way in the future, about 1959, he published his two fundamental postulates. And these are the two postulates that he used to derive a theoretical universe. So if my postulates are correct, this is how the universe would work. And then he eventually, in his books, more or less compared his theoretical universe with the universe that the legacy scientists had discovered through their observations and measurements. And usually had a pretty close match to the most modern findings, but especially in terms of the Newtonian mechanics, and then not so much in terms of the Einsteinian relativistic stuff. And so Larson ended up writing a book that was called Beyond Newton. He saw his advances kind of proceeding from Newton and not from Einstein. And we will look into that a little bit here today, because we're looking at a paper that was written by one of Larson's followers, Dr. Bruce Peret, called the Lorentz factor. And this is one of the mathematical solutions that Einstein used to figure out the kind of the shrinkage of time that occurs at very high velocities. But first, we'll go back to Larson's fundamental postulates. His first postulate is by far more important, and it is that the universe is composed entirely of one component, motion. Not matter, not energy, not even force, but motion. Existing in 3 dimensions, in discrete units, and with 2 reciprocal aspects, space and time. So, and then the second postulate is that the universe conforms to the relations of ordinary commutative mathematics. Its primary magnitudes are absolute and its geometry is Euclidean. Now, Larson did get some pushback for his second postulate from Dr. Peret, especially in terms of using Euclidean geometry instead of Peret's. He favored using projective geometry, of which Euclidean geometry is just a subset. So it's not an outright, disagreement. It's just kind of expanding the scope of the geometry yes, Euclidean geometry is correct, but it's not only Euclidean geometry. There are other subsets, other aspects of projective geometry that also need to be included. Particularly, it's like a geometrical cascade from projective geometry to affine geometry to metric geometry, then to Euclidean geometry as the most specific kind. Peret also rejected the concept of commutative mathematics and of primary magnitudes. So he got rid of that part in the second postulate, but the first postulate is where the more important aspects are. The universe is made out of motion. Motion is the relationship between space and time. Basically, motion is a fraction with space or time as the numerator and time or space as the denominator. Such as speed. Speed is, the bicycle is moving at 15 miles per hour. 15 miles of space in 1 hour of time. Space over time is speed. And you can see that there is a reciprocal relationship going on there. If you try to double the speed, you could say, instead of saying 15 miles an hour, you can say the bicycle is moving 30 miles per hour. Or you can say the bicycle is moving 15 miles per half hour. You can either multiply the space or you can divide the time. That is the hallmark of a reciprocal. Another thing about a reciprocal is that both entities have the same qualities. Whatever qualities adhere to one also adhere to the other. Like 3 and 1/3. 3 over 1 and 1 over 3. They both have the same numbers, but they are inverted. And they both multiply to make 1. You multiply them together and you get 1. So those are some things about reciprocals that help out when trying to kind of unpack Larson's theory. So he says that the universe is composed entirely of motion in 3 dimensions. This is what he calls coordinate space and coordinate time. Coordinate space, we're accustomed to that idea, X, Y, Z coordinates in space or volume. And, we're accustomed to thinking of things being in 3D. But in time, not so much. But since these qualities, apply when you're talking about space, by definition, they also apply when you're talking about time. That's what Larson calls coordinate time. And then we have this concept of progression. Larson refers to that as clock time and clock space. The thing that we can notice the most about time from our vantage point is that time is continually progressing. It's always getting later and later and later and later, and but in no specific direction. So too, then we would be able to posit that space is always getting farther and farther and farther apart, but in no specific direction. And you would use something like a balloon with dots on it to model this. If you blow up the balloon, all of the dots are moving away from each other, but in no specific direction. The farther away they are, the faster they're moving away from each other. And this was actually observed by the Hubble telescope, determining that all of the distant galaxies are moving away from each other. So this is a motion that somehow exists in the universe, but has never been actually recognized in its importance until Larsen came along. It's what you call scalar motion, a motion that has a magnitude, but it has no specific direction. And Larsen took the scalar motion and he placed it at the center of his fundamental theory, his fundamental postulates. Now, I'm not sure why he didn't use the actual term scalar motion in his first postulate. The universe is composed entirely of one component, scalar motion, existing in 3 dimensions, in discrete units, and with 2 reciprocal aspects, space and time. Now, but that for Larsen is clock space. Space is always getting farther and farther and farther apart. Then we have the discrete units part. Space and time come only, and motion, come only in discrete units. You have to have a full unit of space in order to have space. And you have to have a full unit of time in order to have time. Now, when you're saying have space or have time, you're abstracting. You're seeing one separate from the other, but that's not really true. Space and time do not exist independently. They only exist together in motion. They only exist, you have to have really both. And so motion is either time over space or space over time. And it can be in multiple dimensions, depending on the scientific units you're talking about, which is a great check for Larsen's system, checking the units based on their space-time coordinates. Speed as space over time, energy, time over space, acceleration, space over time to the second power, force, time over space to the second power. Matter turns out to be time to the third power over space to the third power. And you can plug these into all your classical equations, make sure that the units come out correctly. This is a much more usable system than the MKS system, which uses mass and then time and then space. Mass is what confuses the whole system, but if you only have 2 components, you can make much greater headway. Anyway, space and time have only discrete units. If you have exactly 1 unit of space in 1 unit of time, you have the speed of light. Larsen refers to the speed of light as unit speed. 1 over 1 equals 1. And this unit speed is really the 1 that reciprocals multiply out to. This 1 is really the center, or the 0 point, the null point, the state of rest, the origin, the ether of the universe of motion. The universe of motion makes sense that the first thing, the primary thing, is motion, outward at the speed of light in all directions. That is what Larsen refers to as the progression of the natural reference system, and this is omnipresent. It's always there, and it is viewed by us as complete nothingness, or a featureless uniformity. And in order to have actual phenomena, you have to have displacement from that speed of light boundary. The speed of light is a boundary between 2 different sectors of the universe, which Larsen refers to as the material sector, that sector that's moving slower than the speed of light, and the cosmic sector, that sector that is moving faster than the speed of light. And again, to show the reciprocal aspect, if you cross over from the material sector to the cosmic sector, you have to invert your space-time relationships. So in the material sector, you have coordinate space, 3 dimensions of space, and you have clock time, progressing time, always getting later and later and later. If you cross that speed of light boundary, then you move into the cosmic sector, then you discover that you have coordinate time, 3 dimensions of time, and you have clock space. Space is always getting farther and farther and farther apart. This is something that we're not accustomed to, viewing the universe that way, but it is consistent reciprocally. Okay, now let's try to get to this paper here, RS2-108 from Bruce Peret. It's called the Lorentz factor. This is a paper that he wrote back in 2015. The Lorentz factor is the name of the factor by which time, length, and relativistic mass change for an object while that object is moving, and is often written with a gamma. This number is determined by the object's speed in the following way. And you get the square root, gamma equals the square root of the quantity 1 minus the velocity squared over the speed of light squared. That whole quantity is in the square root. The square root of the quantity 1 minus v squared, velocity squared, over the speed of light squared. Where v is the speed of the object, and c is the speed of light, expressed in the same units as your speed. The quantity v over c is often labeled with beta, and so the above equation can be rewritten as the square root of the quantity 1 minus beta squared. Let's examine the Lorentz equation to see what it is actually describing. In the reciprocal system, the speed of light, c, is unity, 1.0, in natural units of space and time. 1 unit of space per 1 unit of time. Conventional science uses man-made units, so-called, that are derived by some kind of consensus. For example, the meter, meaning measure, was defined as 1/10,000,000th of the distance between the North Pole and the equator. For the most part, conventional units are arbitrary. However, the reciprocal system's natural units are a consequence of the structure of nature, inherent in everything. Starting with the velocity component, the factor v over c is simply normalization to unity, much like converting a range of values to percentages. Since the value of c is 1.0 in the reciprocal system, the velocity in natural units is already normalized, and this can just be reduced to v, making the concept of beta unnecessary, as beta represents the same consequence for arbitrary units. We now have a normalized system of 1 minus v squared. Now, I think it's the square root of that, square root of 1 minus v squared. Knowing that unity is the speed of light, this part of the equation is actually saying that c minus v squared in natural units, because c equals 1, c times n equals 1. And n can have any value. So this part of the equation is actually I think there's a word missing there. Sorry. But when the square root function is considered, it becomes apparent that n equals 2, and this Lorentz factor is nothing more than the disguised equation of a right triangle that has been adjusted to express the speed of light as a unit hypotenuse. So the long end of a right triangle is the 1, and then the two sides of the triangle are, x squared plus y squared, if you're using the Pythagorean theorem. So, so he's saying here, gamma squared equals c squared minus v squared. And then the speed of light squared equals gamma squared plus v squared c squared equals gamma squared plus v squared, because c equals 1. So I'm reading it anyway. Alas, science also tends to overlook one of the more interesting properties of the square root, that the function returns two solutions, a positive one and a negative one. Because when you multiply two negative numbers, you also get a positive number. So if you're looking to get, for example, the square root of 1, you can have 1, or you can have negative 1. Or the square root of 4, you can have 2, or you can have negative 2. The negative 1 is ignored, though the absolute value is never included in the Lorentz equation, because it would indicate that time, length, and relativistic mass would also be negative. But if you consider both solutions simultaneously, then a bigger problem arises. They cancel each other out, and you end up with the classic division by 0 problem that allows you to do things like proving that 2 equals 1. So don't mention it and hope nobody notices. One should also note that the equation for a right triangle is also the equation of a circle, where r is the radius, because r equals c equals 1. This is a unit circle with the velocity on the x-axis, so that would be like the cosine, and the Lorentz factor being the corresponding value on the y-axis, or this, that would be the cosine. By plotting by plotting v as the x-axis, and then, or the x, and 1 over gamma as the y in its entirety, the reciprocal relationship becomes clearer. What immediately stands out is that a velocity can drop all the way to -1, the speed of light running backwards. That may sound a bit strange, but once identified in conventional terms, it is a very, very familiar concept. Now, just remember when you have, you go back to your expanding balloon with dots on it model. When you're blowing up the balloon, the model is basically that you're blowing up the balloon at the speed of light. All of the dots are moving away from each other, and that is what Larson calls the progression of the natural reference system. And but you can have the negative of that, what you would call the reciprocal of that, which is if you sucked in the balloon. If you suck in the balloon, all of the dots are moving toward each other. And that is the phenomenon that we call gravity. Gravity is when all of the dots, it's a scalar motion of the dots moving toward each other. We make the mistake of thinking of gravity as being somewhat of a field, where one dot is moving toward another dot. But that conception of gravity relies upon us assigning a reference point to one of the dots. If we decide that one of the dots is motionless arbitrarily, then we can start assigning directions to the motions of the other dots in relation to that non-moving dot. So that's where we get these erroneous concepts of gravitational fields. But gravity in Larson's concept is a scalar motion, and it's not a motion of any body moving to any other body. It's a movement of all bodies toward all other bodies. Okay, so he has a figure here. The reciprocal system, the speed of light, unit speed, is the fulcrum between motion in space and motion in time, or the boundary between motion in space and motion in time. As such, it is the upper limit of both of these motions. So I guess that's why he's using fulcrum, because he's using the term motion in space and motion in time. Well, the motion in space is speed, but the motion in time is energy. And so motion in space increases up until it gets to 1, the speed of light. And then we generally think of then the motion is going, when it goes beyond the speed of light, it's greater than the speed of light. The speed is greater than the speed of light, but motion in time is measured in energy. And so motion energy starts at 0 and it maxes out at 1 at the speed of light. So because it's reciprocal of speed, time over space as opposed to space over time. So that 1, that speed of light, is actually the maximum speed in either sector, because speed goes from 0 to 1 and energy goes from 0 to 1. So as such, it is the upper limit of both of these motions, essentially being the maximum speed of the universe, which is referred to as the progression of the natural reference system. So if you look at it that way, then Einstein is more or less, he's correct, saying that the speed of light is the maximum speed of the universe. But that's if you're like equating speed with energy. But energy is actually inverse speed. Okay, I think we're going to leave it right there for today, and we will resume this paper tomorrow when we start up. Let's see. Yeah, this paper will take a few days to get through. Well, maybe 2 more days. It's an interesting approach. I haven't quite gotten my head around using a unit circle and using a right triangle to map out the Lorentz contraction. But I'm going to sleep on it and see if I can kind of suss it out in my head and understand it. That's what I encourage you to do as well, to just let it wash over you. Don't reject anything out of hand just because it's an unfamiliar concept or something you haven't thought about before, or something that disagrees with what you already know, what you already, quote, know. And, you know, that's the way that you learn the reciprocal system, is by not suspending disbelief and recognizing that you're dealing with an entirely new paradigm, and that it's very easy to reject it with the circular reasoning of your old paradigm. But if you are really being honest with the truth, just take it in and say, well, I don't really have the capabilities of evaluating this quite yet. I need to see more. I need to have a bigger picture, a clearer picture before I can actually reject this. Okay, thanks for tuning in today. Have a great night.